Hey guys, how's everything going? This is JSer. This video is about TypeScript. I love TypeScript, though I'm not an expert. So in this video, let's take a look at the Generix, which is the most powerful feature I think TypeScript has for us. Okay, what is Generix? Generix is, you could think of it like a template, and let's just jump straight into the example. We could create a function like this with the argument as a number and return a number, and you just return itself, right? So this argument could be anything. So you could naturally think, okay, anything, I will use any, but this is not working actually. If you use any and return as an any, actually you could return 1 here, right? It is still, the TypeScript doesn't complain about it because you said the argument is any and return any. It doesn't mean that these two should be the same type, right? So this is where the Generix is. If you want to create arguments, return number, arguments number, return number, we could use a type variable, which is big T with these angle brackets. And so this function now becomes a generic function. It is actually a function template. And once you want to create a function called like identity, if you want to use it as a string, you could say identity string and something. And so this, now the result actually is string because you said it's string, so the argument is string and the return value is string. You cannot, if you say string here, you cannot say you pass a number because it doesn't match the type. Now let's say the type of identity, you see the type is, okay, type font equals type of identity. Now the function actually is, you see the type is argument is t, return a t, and this is a generic function. So this is a generic function, pretty easy. And this is just a template. Okay, but actually I will talk about it later. So rather than the template, I could think of something else. I'll come back to that later. Okay. And another thing is that actually the TypeScript has this powerful type argument inference. It is clever enough that we don't actually need to pass the string here, because you said the argument is t and you pass the string, so the segment here means that it should be a string, right? So actually we could omit it, and the result is still string. Yeah, this is argument typing inference. And this is our generic function, and because it's generic, there will be any type, so you cannot call the type specific properties, right? The nth don't exist in array and a string. If it is past a number, it doesn't match, so TypeScript will complain if you call something that does not exist on the generic type. And this is when you need to where is it? Use the constraint. Oh, let me take a look. Okay, we will cover it later. So the paragraph says you just change it to change it to the types with the length. This is array here. Okay, t. The argument is array of t and return array of t. Nothing special. Generic types. Generic types means that we could define the type of function, right? This is a here. This is a type of a function, as we have shown here. This is a type. Argument is a u, returning u, and this is generic, so we use an angle bracket. Well, this is nothing special. So this is the interface of a function, type function. Because it's generic, we add this t to this constructor function. No, call signature, argument is t, return t, and we could, and this function actually has this interface, so we could assign this function to the this variable Nothing special. It's not possible to create generic enums and namespaces. And still, we have as generic classes. We have this class, and we could make it general. So now it becomes a template. We could use any type we want, right? Here we create this class with the number. So yeah, and so the values number, the add function method accepts a number and returns a new number. So this is how it works for generic classes. But actually actually this example does not pass the issue errors. You said even for generic functions, this is strictly required to be initialized, right? You cannot. This has no initializer. We need to configure. Actually, the strict property initialization requires it to be initialized. So we turn it off. There will be no error. Yeah, we define a numeric now with a string, so we could assign it to string. If now we assign a number, it will be error because we know should be a string. Generic function. Now this is generic constraint, right? We create a generic function. We call it a length, which only exists in string or array. So this generic function actually is not that generic. It doesn't work on all the types. We could narrow it down. We could array down, say, okay, this is generic, but the T should be only something lengthwise, has the length property. Yeah, it means this is a generic function, but the type only should be have the ones which have the length property, so we can call it, right? Now the args, you see that is lengthwise, this has the length. Now we could call it logging identity. We could call it a string. String has length. We could call an array. Yeah. And we cannot create a number because number doesn't have the length, right? So we use extends. This extends is different from this extends. Literally, from the spelling, it's the same as the class extends, but it's just in the type world, right? This is type world. This is JavaScript world. This is type world. So it means the T belongs to lengthwise. Well, this is a type restraint. You must switch to the type world. This is not extension. It means it should be it should comply to the interface here. So yeah, so we narrow it down. Now this generic function is not that narrow. It's not that generic. It's I would say somewhat a generic. Okay. Use type parameters. Okay, this is another interesting one. Okay, let's see what happens. We have a generic function, which object is T, key is K, and so we say declare the type variable T and K, and we say K must be the key of T, right? Extend key of T. Okay. So when we have this object, we get X A exists, so it's okay. But X called with M doesn't exist in X, so this does not work, right? This doesn't match, so it fails. It tells us that M is not assignable to the parameter. Type parameter should be A, B, C, D. Of course, if we say something like M4, it works again. So now, with these two examples, actually, I think we have come to see what's the fundamentals of this type Generix, right? Okay, this one is class type. What is it? We will come back at the end of this video. Okay, using class types in Generix, so we could use this is a factory function, which create instances without new. Create, this is a class. We cannot, T here is the public site of the class, so we should declare refer to the type of the class with this call signature, new, okay. So now if we create an instance A, it should be some of the animal, and then we say we should return an A. So when we call with a lion, this function actually returns a lion. So now it says, okay, I know it is a lion. So we have the name tag. Name tag equals to zookeeper. Lion is zookeeper. A lion is zookeeper is zookeeper. B zookeeper is beekeeper. Beekeeper has mask. Okay, name tag has mask. So yeah. So with these two examples here, we actually know that Generix, the power of Generix is that we declare some rules that the type rule should work, right? Let's take a look example at this one. So without it, object actually cannot be used to index t, because the t, key is k. K could be anything. Anything cannot be should not be retrieved from any object, right? It doesn't the key doesn't exist in the object. So actually, we add the constraint, say key must be extends key of t, right? Okay, it works. But why would we need to add this thing like this? So if you take the remove the type, it would be something like this in the JavaScript. Actually, it's not safe. Key is not part of the key of the object. We define the generic. It actually means the same. We would say t and k for key. This is not a very good example. If we return something, return the like t, return object. It means that we add some, not the type variable only, but the whole type is to make it more concise, right? I mean, you can think of the we're adding some rules. The rules might not be fully what you want, but the TypeScript will help us dig into the rules to see that if it is right or not. Take a look at the identity here. Okay. This is identity, right? It means that we need to add a rule to let TypeScript know that the type returned is the same with the type passed in. So this is a rule we want to do. So we add a rule. Say return type should be same with parameters. Okay, argument type. To achieve this, we use arg t, because this is a template. This is a rule. The TypeScript will take this rule to your function implementation to see if it is matched or not. It might be not enough, but it works for the specific rule, right? Before it, it's something like this. Now we add it, right? Say this rule must be true. Then TypeScript say, okay, I add it like this. It will check for us. Now let's take a look at the example here. Get the property. Without it, okay, this is something like this, right? Okay, now it says, okay, the first rule, one key must be part of object, right? We just actually want to add this rule. So how should we do it? Well, key should be part of the object, then it should be type of object, right? But object is any object. We don't know, right? We don't know what the type is. So we should use what? Use this placeholder, which to declare the variables. Okay, I want to get the type of object, but we cannot get directly from the object because it's unknown to us. So we define the rule. Say, okay, we declare the variable t. Object has this t. Now you can refer to this t as you want. So key of t. Something wrong? Oh, there's no. Lacks return notation. Return? Okay, I'll comment this out. This is not angle bracket. I'm sorry. It's a T. So this is okay. It's done. Right? It's the same as we used before. You can say extend the key of t, and use t here. Extend key of t. Okay, this is k. I'm sorry. Yeah, so this is true. It have a different approach that okay, he says, okay, the type of object is t, type of key is k, so these two must be have this relationship. But I think the previous one we wrote is a little much easier to understand, right? So it says, let's do this again. It's very important to understand the magic of the TypeScript. Okay, so we want to say the key must be part of the object keys. So the type would be what? So it should be key of type of object, but I cannot get the type of object like this, right? Because you mean the object don't know what the type of object until it's in a runtime, but TypeScript will handle it in the build time, a compile time. So we don't know what it is. We only can get the rule, say they must be the same. So we say, okay, so if the type is t, we need to get the t, then it should declare the function as a generic function, so t. Now the key should be key of t, right? That's it. So this will still work. Okay, I forgot the key here. Yeah, if we use something else like m, it will be wrong, right? It's not assignable to it. So yeah, let's wrap it up. Generix actually just apply some rules to our functions. It is not the full. It is not a full. How to say? It is it might doesn't work fully as what we want. It doesn't know what we want to get. It doesn't check the completeness of your target, right? It just means a rule, and TypeScript will check that if the rule is matched. If it is matched, okay. It just checks if there's errors or not. It doesn't mean that it is what you want. Okay, so this means that you add a rule, say the key of the type of key must be part of the key of the object. So TypeScript just check that. It will like this is regular expression. JavaScript will put your code to that type interface to check. Okay, it's matched. Just okay, matched or not. Okay, so TS just check your code against the type like a regular expression. Not to check the completeness, but only to find errors according to your rules, if any. Yeah, okay, that's it. So in the future, we will meet a lot of type magic like these utility types. So like, okay, the pick and omit and exclude, something like this. Extract and non-notable. Yeah, remember, they're just some templates. A regular string, okay, we can think of it like yeah, template and irregular expressions, TypeScript only to find the errors, not the completeness. Yeah, because TypeScript is not the static language, right? They just add progressively or gradually add types to your code. It doesn't require the type static types from the beginning. So it doesn't check the completeness, just only, yeah. This is it. Very important. This is the Generix. It is very important. Please to read the document and to get the intuitive impression of how it works. This is my understanding. We just add some small rules little by little to make it better and better. And yeah. Yeah, that's it. Hope it helps. See you next time. Bye bye.